Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. I'm so happy to welcome you here to another episode of the azure-cosmos-db Certification Study Hall. And today we're going to talk about something very exciting, something I really love talking about. It's authoring complex queries with the Azure Cosmos DB SQL API. And I really can't wait to get started. But first, I want to introduce myself. My name is Marilag Dimatulac, and I am an Azure MVP, and I'm also a tech entrepreneur. I run my own software development company. In fact, we actually use Cosmos DB a lot with our customers. And I think the first time I started Cosmos DB was way back when it was still called Document DB, but I'm still really learning a lot. So I'm really excited to host this episode. But I'm more excited that I'm doing this with none other than Team Sander from the Cosmos DB product team. Hello, team. Hi.
Hi, Marilag. How's it going?
Really good. Really good.
Great to be here today. Today we'll talk about one of my favorite subjects in Cosmos DB, of course, which is queries. We'll talk about how, to write complex queries in Cosmos DB, talk about a lot of great things. I'm a product manager that focuses on the core query engine in Cosmos DB. That's the query engine that's used in SQL API, our API for MongoDB, and the other APIs for Cosmos DB. Today, we'll be focusing on our SQL API, but a lot of the concepts that you learned today could be, generalized to Cosmos DB as a whole. I'm a product manager, on the engineering team, right? So, throughout this session today, I love to hear feedback, questions from you. We'll really be covering a lot of the topics that I love to talk about, but we really want to take it in the direction that most interests you in preparing for and learning about Cosmos DB in the exam.
Awesome. And I'm really sure that we're going to get a lot of questions now that you're here. And I know that you also write a lot of blogs about Cosmos DB. I know for sure because I've read some of those, and when I needed something or looking up something. So it's super helpful. That's why I'm really excited to do it right next to you. So maybe I'm just going to throw all the questions to you, team.
Awesome. That's great.
Right. Yeah, so I just wanted to let everyone know that this is actually a series of sessions based on the Cosmos DB Microsoft Learn modules, and we bring it to you live so that you can learn in a bit more fun, interactive way. And this episode is actually a continuation of the episode that we did last week, where we started with some of the fundamentals of querying Cosmos DB using SQL API. And this is actually episode 10, if I'm not mistaken. Yes, there are a total of 15 episodes. Yeah, there are a total of 15 episodes. So I'm sure there are some of our viewers right now, or some loyal viewers who started from episode 1, and where we talked about some of the other fundamental things, and also about how to model data, and of course how to use the SDK properly, and also other point operations like reading and writing or updating your data. But today we are focusing on the exciting stuff, which is complex queries. And I'm sure this is a topic that that can maybe confuse a lot of people, especially if they came from a different world, a different platform. So everything looks familiar in a way, but still there's subtle differences, and it's really, really good to know the basic, and you're here to teach them, team. So right. So if you are doing this with us live, you don't have to go through the modules while we're doing it. It's fine that you can do it after at your own time, self-paced. And if you are watching the recording, then please do check out the MS Learn module so that you can complete some of the interactive learning exercises, watch some of the videos, and practice your skills. And for today, you mentioned a little bit about our, what are we going to talk about, team. So let's look at our learning objectives. So today we want to implement correlated subquery, and team is going to really walk through us and give us a deep dive on how this works and how it helps us make efficient calls against Cosmos DB. We will also learn about something a bit more basic, how to do cross-product query, but there's also some tips and tricks that probably you are not aware of that we can let you know, and how to implement variables in queries, and of course, lastly, how to paginate query results. These are really, really important skills when you're working with Cosmos DB. And there's actually a really good way for you to demonstrate the skills that you have learned all throughout this series. Also to go to your employers and show, hey, I'm a really good Cosmos DB expert. So there's a good way for you to do that, and that is through this new certification. Team, why don't you tell us a little bit about the Cosmos DB certification program?
Absolutely. So, I mean, this certification is a really awesome way to show off and prove your skills in Cosmos DB. I mean, Cosmos DB as a product, I mean, it's gives you and empowers you new ways to work with data through rich data modeling, querying, partitioning, and things like that. And preparing for this exam is a really great way to learn a lot of that stuff, right? And the Learn modules can certainly help you do that. And when you're ready to go and prove your knowledge, right, and demonstrate your knowledge, this exam is a really great way to get certified in developing data solutions on top of Cosmos DB. So I'd recommend go check it out. It's a great exam to show off your knowledge.
Yeah, absolutely. And I think it is a beta version right now. You can check it out. So yeah, but you can try it out. And I just remember when I did the Azure developer, there were a lot of Cosmos DB questions in this one, but now they have put it in one separate certification, which is really great. All right, but the thing is, ever since, I'm really, really happy with the way the product team is helping Cosmos DB users and developers really gain the knowledge that they need to optimize their usage of Cosmos DB. So I want to take this opportunity to thank the product team, the product managers and our organizers, our producers, and of course our community leaders who is actually making all this series possible. And so I just want to say thank you to Chris Hyde again. He's our moderator for today. Chris Hyde is also a fellow MVP for the Microsoft Data Platform, and he will be behind the scene. He's not going to be on live with us today, but he's live because he's actually the one dodging all the questions before it get to us, team. So do ask your questions on the chat. And well, speaking of questions, so if you are joining us live today on different channels, we are on MS Learn Live TV, we are on YouTube, on Twitch. And so please make sure you head over, say hi. When you ask your questions, we can go through some of them, and like Team has promised, he's going to answer as much as as he could. And but if we don't get to go through this, again, Chris will help you out and some of our subject matter experts that are behind the scene. So we have everything. We got you covered. So let's get started with our module here, team. Shall we?
Yeah, that sounds great.
Good. Exciting. All right. So querying and complex queries. So let's start with thinking, if you have been working with NoSQL database or when you work with JSON document databases, you would typically see that you model your one-to-many relationships a little bit differently. So you actually put all the data within a single document, and you would typically find either child documents or an array of objects or array of items or child arrays within the same document. And so let's say, for example, let's take a data like a family. So a family will typically contain the names of, the guardians or the parents, and then you would have children, zero or more number of children, which are represented as array. And in the relational database, it's very common to put those two different data, the parents and the children, in two different tables, but and then create the relationship via the foreign key. But in NoSQL databases, you will find all this data within the same document. So how do you then write queries with such a structure? And that's what we're going to learn with this module. We already mentioned that, some of this complex expression that perhaps looks similar, but in fact different than the typical SQL language, you will encounter that. And it will help you a lot as a developer to understand the best practice, especially just in the context of Cosmos DB, but in general, in the context of a NoSQL type databases. So what is the recommended way of using the SDK, and how do you do filtering, and how do you page through the query results in an efficient manner? So let's get started with the cross-product query. So if you have been working, again, with relational database, you're probably familiar with writing cross-product queries using joins. So joins is ubiquitous in the database world. So, but joins have slightly different meaning in Cosmos DB because you're only, as I have mentioned, working with the data that you find within the same document. And cross-product queries simply means that you're combining two or more sets of data into a single set with all the possible permutations or combinations of data from each of the sets. So for example, here you can see in set one, you have a single product with an ID and a name, whereas in set two, you have two different groups in that set, which is accessories and new. And when you do cross-product queries, you're actually essentially creating a third set where you combine set one and set two. So now you'd have two items with the two instances of the product, each with map to each of the group, which is accessories and new. So again, in relational databases, set one and set two would be two different tables, and then you do the join and you get this result. How does this look now in Cosmos DB? JSON document. So instead of having two tables, you actually have one document here. You find the ID and the name as one of the properties, and then you have an array of groups, which is an array of objects with a property called group that has the value of that group. So you won't have two different documents typically. You can do that, but that's a different story with the data modeling. There are different scenarios where we can get to that, or you can put a list of groups into a different container. But again, that's a different story. It depends really on your use case. But in most cases, you can take advantage of the power of a NoSQL database if you model your data this way. And this is very, very suitable for cases like this where there is a one-to-many relationship. So creating a cross product of name and group properties will end up in this kind of result. Then you would have an array of, or a JSON array with objects that has both the name of the product, if you selected the name, and the name of the group combined together. So now you have three items. And this, you always need this. This is something that's very common for application developers so that they can iterate with the result set easier. So how do you create this in Cosmos DB? Let's take a different example of JSON. The first one was a little bit more simple. Now let's make it a little bit complex structure where this is a document for a product, and observe that this product has a list or an array of tags, which is more complex. So you don't only have one property of string, but you actually have three different properties here. And note that one of the properties, if you look at the attribute of the product, there's a name that represents the product name. And under each tag, you also have a name, which in this case is the name which represents the value of the tag. So how do you actually get to this point if you want this result where the value of the tag, which is apparel worn, is named as tag? And then the name of the product still stays as a name. So this is a typical query structure for a select statement. So it's very similar to your select from statement, but in order to do cross-product queries, you use the join. So we do have actually the join keyword in Cosmos DB, but you're actually joining it with the array of tags that you find in the same document, and then you give it an alias as T, and then you can refer to the property of tags in your select list, like perhaps T name, and give it another alias as tag. So essentially, you are getting or producing a cross-product query between the product and the list of tags. So for each product and for each tag, you will have one item in the resulting JSON array. And where your tag becomes, or the name of your tag becomes alias as tag, as you have seen in the previous result. So it's pretty simple. I just want to emphasize that if you have tags, let's say, stored in a different container, if you model it that way, so you only kept, let's say, the ID of the tags in your product document and then put the group, the tags in a different container, then this join won't work because join is scoped only within the single document. So you really have to think about your data model, how you can implement that, maybe through their normalization to represent the relationship between two different data sets. And if you do denormalize your data, so let's say you have this, the groups and the tags and the tag name is in the product document, and you have another container where you also have tags stored, And what if you update the tags in one of the containers? Then you have to handle how to, of course, update also the names of the tags in the product, maybe using the Cosmos DB change feed, which you will learn also in some of the subsequent episodes. Yeah, so that is cross product queries for you. And so now that we have learned cross product queries, how can we then use this in a bit more optimized way? And Team Sander is going to show us the next topic, which is using subqueries.
Awesome. Thank you so much, Marilag. And that was great. I mean, that you covered the basics of, joins in Cosmos DB. When I actually joined the Cosmos DB product team about 4 years ago, that word actually, it took me a while for me to wrap my head around it, right? Like when I thought of join, I always thought like, oh, relational database join. And anytime I would type to query a Cosmos DB collection, I'd actually kind of default to using the same syntax that we use in like T-SQL or other like query languages to query relational databases. And that's not at all what it is in Cosmos DB, right? If it helps you think about it, you could almost even replace the word join in your mind with cross product. Because like Marilag mentioned, that's effectively what you're doing. It's join in the sense that that's just the name we've chosen for it, but it serves a very different purpose than joins in a relational database, right? Because it's scoped to effectively a single document.
Yeah.
Now, correlated subqueries are a feature that we have in Cosmos DB, and they give you a lot of functionality for querying arrays and querying them in an optimal way. Now, before we had correlated subqueries, back years ago in the product, you were actually kind of limited in how you queried arrays. And every time you wanted to go filter on something within an array, you had to use a join. Now with subqueries, we've actually given you some additional options for if you need to use a join, going and optimizing it. And then in some instances, actually going and avoiding the join entirely and really simplifying writing queries that go and filter on data within arrays. I'll cover 4 different use cases of correlated subqueries today. The basics of correlated subqueries here the concept is really similar to any other database that has subqueries. So I'll just show a quick example, and I'll talk about kind of the structure of the subquery before I kind of go into like why we use them in Cosmos specifically. The first use case that we'll cover for correlated subqueries is optimizing join expressions. So in the previous examples, Marilag showed a lot of great instances for why you'd want to use a join in Cosmos DB. And like Marilag mentioned, joins are scoped within a single document in Cosmos DB. And if it's easier, you should think of a join as a cross product, right, between 2 different portions of the document. You can use subqueries within a join to actually filter down the amount of data that needs to be joined together. For example, let's say we had this document here. It's actually, I think, the same document, Marilag, that you had shown in your examples. We have some like root level properties here, and then we have a small tags array that has 3 elements within the array. Each of the array elements has an ID, name, and class property. Now, in one of your earlier examples, you had a query that looked somewhat similar to this here. It wasn't exactly the same, but it had a similar pattern where basically we went and we joined the array elements here, right, with these root level properties, and effectively took the cross product of these root level properties, which each of the 3 array elements. In some instances, of course, you might want to go and filter on that, right? Like you might want to do that cross product and then filter to, let's say, array elements where the class is equal to trade-in. And if you wrote the query like this, if you wrote it with join and without a subquery, it'll run, it'll work, but you could improve query performance quite a bit if you added in this subquery here. If you go and add in this subquery within the join, we'll go and we'll filter into tags with the class trade-in before we even bother doing the join. So if, for instance, only a small number of classes have the value trade-in, it would make the join much cheaper because it would effectively like decrease the number of combinations, right, that we needed to do the cross product of. Now, taking a step back, because I mentioned I'd talk about, just compare subqueries in Cosmos DB to subqueries in like SQL Server, for instance. In general, the concept here is the same. The key difference, of course, is this inner query here has to be kind of related to the outer query. In other words, the inner query and the outer query have to be correlated in nature. You can't have like a fully independent subquery that's effectively fully independent from the outer query. If you look the outer query references T here, and that same value we actually use in the inner query. So that makes it effectively like a correlated subquery, hence the name. But I mean, the syntax for subqueries and the structure for writing them is roughly similar to if you were used to using them in a relational database. Now, for this sample document here, going back to the example, if we were to run this query, it's basically going to get the count of array elements that have the class value trade-in, right? So in this example here, we'd run the query and we'll do a join of all the tags that have the class trade-in with this root element here, right? So if we take this root element, we'll do a join with the first tag, second tag, and third tag. Of course, because this has the class equals trade-in filter, we can actually skip this first one here. So for this specific query, writing it as a subquery would improve performance because we would only need to take the cross product with these two array elements rather than all three. And you can imagine if this array was much larger, right? If let's say there were hundreds or thousands or tens of thousands possible values within this array, I mean, it's certainly possible that the savings here could be really significant. And I see that we actually have a question that came in on Twitch, which is really awesome to see. And the question is, what if you put a filter on the on part of the join instead? And that's actually a great kind of point to circle back to. There isn't an on in the join in Cosmos DB, right? In a relational database, there's different types of join, right? You could have like an inner join that joins on a particular property. In Cosmos DB, it's more of just a cross product, right? There isn't a particular property that we're joining on. We just take the cross product of all the elements in the tag array with this these root level properties. And there isn't like a particular property that we're going and we're matching between them or anything like that. Now, going and still thinking about optimization for subqueries, another reason you might want to use subqueries in Cosmos DB would be to evaluate an expensive expression once and then go and reference it many other times in the query. This is common for if you're using UDFs in Cosmos DB, user-defined functions, and it's also common if you're using, let's say, aggregate system functions in Cosmos DB, which can occasionally be inefficient and maybe not use the index as efficiently as like your if you use a subquery, you can go and you can reference the expression once and then use it in your select clause, where clause, without having to go and evaluate it again and again and again. Now, this comes up, I would say, most often with user-defined functions. And in this example here, we have a user-defined function named calculate tax that takes in price as an input. And basically what this user-defined function does is it calculates the tax based on this product's price. And if we were to write the query up here without a subquery, and we wanted to project the tax amount in the select clause and also filter on it in the where clause, in other words, basically filter to all the items where the tax will be greater than 10 and return the ID and tax amount for those items. If we wanted to do that, we're going to need to, for every single item, perform the calculation for this user-defined function twice. In other words, we'll need to calculate it to show it in the select clause and also calculate it to show it in the where clause. And one way you could go and optimize that is with a subquery. You could rewrite the query to kind of look like this with the join, and then put the UDF here in a subquery. And this subquery isn't going to have a filter or anything. It's just going to project the value of the UDF on the price property, and then go and alias that as tax using as. And once you do that, you could use it in your where clause, you could use it in the select clause, and you won't need to go and calculate it again and again and again for that document. So, I mean, for this query here, the cost of calculating the UDF will effectively be about half of that of the query above, because we need to calculate it just one time, we alias it, and we reference it again, as opposed to calculating it separately for the select clause and the where clause.
Team, I actually have a question.
Yeah.
Just for those who are new in Cosmos DB, and I can see, value on your select statement. What is that for?
Yeah. So, I mean, when you use value, you're basically just going to go and project those properties as values rather than a big object. So it's not going to make a huge difference in terms of performance or anything like that. But basically, do you want to get an object back in your results, or do you just want to get like the property values back in your results? Basically, it's going to affect the way your results are returned back to the client. And depending on how you wanted to use them, you could, like, let's say you only wanted to get a couple properties back, it might be more advantageous for you to use value rather than getting back like an object with more properties.
All right, thank you.
Yeah. Another reason you'd want to use subqueries would be to mimic join with external reference data. So let's say that you had static external reference data. For instance, let's say you had like measurements. Different measurement abbreviations would correspond maybe to different symbols, to different words and numbers and that sort of thing. And you might want to do a join of your query with this external static reference data. Now, this is conceptually like a relational database inner join query, except the join is with static reference data rather than like a completely other table. In other words, this isn't functionality for cross-document or cross-collection joins. It's functionality for doing a cross product, right, between static text in your query and the data in the doc. So take a look at this example here. Actually uses a slightly different data set just because it was hard to think about, I guess, a use case for static reference data for our data set we have now. This is a data set that contains nutrition information about different food items. So we have different units, names of the measurements, and different like multipliers and English names of the units. And basically, we wanted to do a cross product between the data that we have so far with this static reference data. And I mean, this is effectively how you do it. You'd go and have a subquery with join, and the subquery would have that static text that you could go and reference to basically get things like the units and the name values in your query results. This doesn't come up too much, but it does add a nice convenience factor if you wanted to get this information in your query results rather than like maybe store the static information client side and do a client side join. It can make it so a lot of your app's logic maybe could be put in the actual query rather than some client side logic to go and join your query results with some static data.
So correct me if I'm wrong, I can still actually filter against the values or the properties of the static data there, right?
Absolutely. I mean, this is you could put almost whatever query you want in here. So you could put a where clause, right? You could filter on that. Of course, if it's just like static text, there's probably not a huge need to filter on it. But I mean, you certainly could. You could put whatever query you want in here. In this instance, it just happens to be static text. But let's say you had maybe business logic that you needed to put here to like filter this text dynamically. You could certainly do that as well. Or of course, you could filter on this even outside of the subquery, right? You could certainly do that in your query as well.
Right. So actually I have another, see, I have a lot of questions. This is still mystical to me. So if I have a complex object, so an array of complex objects, so let's say an array that has even more arrays down the line, child arrays, can I also have nested joins in them?
Yeah, you can go and you can nest joins. I think we support, I think it's a pretty good number. I think it might be like 4 or 5 nested joins, somewhere around there. So we support, I mean, a good number of nested joins if you have deep arrays, right? Arrays that like there's an array within an array within an array within an array and so on. And like you mentioned, I mean, nested joins is effectively how you're going to do that. It's good to keep in mind though that there are performance implications to doing that. Like as you can imagine, like the bigger the combinations as you're doing cross products, right? The more expensive it is. So when you're modeling your data, it's totally fine to have deeply nested data, but if it's an operation that you're going to be doing a lot, you do want to think about it carefully. When you're modeling your data in Cosmos DB, you want to model for the operations that are run the most, right? So if you, let's say, had a query that did lots of nested joins, it'd be totally okay if that was just a query you ran once in a while. But if it's like, let's say, a very common query that you run in your application, you might want to think about avoiding like really deeply nested array data. Like maybe a couple levels is fine, but I think the limit right now is 5. Thinking about it more, you probably wouldn't want to go all the way to that limit of 5 levels deep.
All right. Yeah, of course. So there are some performance issue, and I guess difference in your request units as well, depending on how complex your queries are, and again how much data this is being returned, and yeah, how complex your document is in the nested arrays of arrays. So there is certainly some price to pay for that. So good modeling is really a good foundation if you're developing with Cosmos DB.
Absolutely. Modeling is key. And it's funny, like we're talking about queries today, right? And like I work on the query engine, like I love to talk about queries, but if you were going and optimizing a query in Cosmos DB, in most instances, the solution is actually going to involve changing the data model, right? Unlike products like, I mean, relational databases where you'll spend all this time tuning a query, there's actually really not much to tune in Cosmos DB. You'll focus a lot on things like indexing in the data model. And the query engine is actually, I mean, just going to be optimized automatically. Now, in NoSQL databases like Cosmos DB, you get the huge advantage of being able to change the underlying data model, right? So in a relational database, data is always normalized into tables, right? And you're kind of stuck with that. In a NoSQL system like Cosmos DB, you get the added flexibility of customizing your data model to optimize specifically for the kinds of queries you need to run. So while there's instances where you could optimize the query, like we're going to be talking about today, in a lot of cases, the optimization actually involves a fundamental change to the underlying data model, right? That you have so much flexibility with in Cosmos DB. Now, speaking of query optimizations, and actually this is a great transition from your question about, hey, like what if I had deeply nested joins? You can actually use exists in Cosmos DB to completely eliminate and reduce the need for joins. With exists, basically, you can go and filter on data within an array without having to write a query that has a join. And this is going to be a little more efficient, but most importantly, it's just going to be a lot more intuitive to write, right? It's a lot easier to go and understand what these queries with exists are doing rather than queries with arrays. But if you have really large arrays, I mean, this is something that you definitely want to keep in mind. Joins get incredibly expensive in Cosmos DB if you have arrays that have thousands or tens of thousands of elements within them. And exists can be a nice optimization for going in, not only simplifying how these queries work, but also going and reducing the RU charge for them. Now, basically what this query up here does is it takes that like root level properties and it goes and joins them with everything in tags and effectively takes the cross product, right, of the root level properties with everything in tags. And then it goes and filters where the name within tags is equal to no damage, and the ID value contains CA17. Now, in this query here, we're not actually interested in returning any of the data in the tags array, right? If you look, we're just returning the ID value. Maybe we'd be returning a count or something like that. Of course, if you were interested in returning like the name values, so like data that's in tags, you would need to use this join here. But if you didn't need to return that data, you could actually rewrite the query to use exists, where you go and you put exists in your where clause and then add in a subquery that basically filters in tags where the name is equal to not damaged and the ID value contains CA17. In this particular instance, what we're doing is just applying this filter, right, for the documents where this value just exists once. And if that's true, we go and return the ID value. So you don't really need to join because you're not actually going and returning any data from the tags array. So if you can optimize your query in this way, I recommend it. It's mainly going to be a big optimization if you have large arrays. If you have small arrays, could be worth doing, but maybe not as significant. But I mean, if you like Marilag mentioned, if you see yourself in an instance where you're going to have lots of nested joins, do start to think about using exists instead of that, or of course, changing the underlying data model.
Yeah, that really makes a lot of sense. And now that I think about it, and sometimes it's not something when you think about as a developer when you're writing queries, because you tend to get used to one way of writing things. So when I got used to writing the join just to filter my result set based on a property of that array, a child array, then I didn't think about it that, oh yeah, I don't need any of the properties from that array, so I might as well use the exists. So can you just tell me why it is more efficient actually? So what's happening in behind the scene in the query engine? Why checking if it exists is more efficient than joining it first and then filtering it out?
Yeah, so in this particular instance, it's because we're able to avoid the join that we don't need to do it. So we're going and avoiding the full cross product here. And that's what makes this query a lot more efficient. So it's just a factor of the cross product being expensive if it's a large array, and using exists allows us to go and avoid that. It's very similar to the advantage of using a system function called array contains in Cosmos DB. Array contains serves the same benefits. It's more efficient than doing the join. But array contains, of course, it's a little more restrictive because it just takes in a value as input, right? And it just checks if the array contains this value. You can use array contains in instances where array contains works. I would just do that rather than exists. That'll be a little easier for you. But the value of exists is that, I mean, you can put whatever query you want in here to filter, right? So it allows much richer filtering, and it's more efficient because we don't need to do the join in order to go and filter on that data, right? Then we don't need to do that expensive cross product.
Right. So is it going to be faster and less expensive in terms of request units, or just cheaper in request units, but not necessarily faster? So is it both speed and CPU usage that we're talking about savings here?
Yeah, ideally it should be both. I hesitate to put like, I don't know, like a bold claim around that because it really only makes a huge difference when you have large arrays. But it is, like you mentioned, absolutely motivated by saving RUs and saving execution time. These two things kind of go hand in hand. In the later part of the presentation, I might be kind of sloppy and say like, oh, this would save RUs or this would save time. But I mean, most of the time, if you save time, you also save RUs. And if you reduce the latency, right, and save time,
they go hand in hand.
Right? Like they go hand in hand. If one goes lower, the other one usually gets lower as well.
Right. So yeah, really, really interesting to know. Right. Now that we learned, now we have talked a little bit about how to filter out your data. So let's move on to the next topic, and that would be using variables in our queries. And let me share my screen again. Sorry, I'm just going to jump to the topic. All right, so we want to talk about implementing variables in queries. We've seen all these different filters, right? How do we do where clause, where you pass a value? So you can use that in your SQL statements, but then of course, typically you would be using your SDK when you're developing on your chosen platform. Let's say you're developing for a .NET application, so you're using the .NET SDK, and the SDK has a good way for you to be able to do this filtering using parameterized queries. We'll look a little bit on that later. And then you in the SDK, you have the query definition class and the Fluent SDK that you can add query parameters so that you can quickly adjust the values in your where filter for a SQL. So let's take a look at this example. So if you look at this example, this is, yeah, we've seen this now quite a few times today. You have your select statement, you have a from your products, and then you join it with your tags, and then you want to filter it out by price. So this one, we just want to get like the products that have price greater than 500. So this is a very typical query. And if you use the .NET SDK and you're writing in C#, this would typically look like this. You pass a string, and then you pass your value as hard-coded value. It could also be just a variable or an input variable that you receive that you concatenate with the whole string. So you have a string, and then you pass that to your query definition. And this will, of course, definitely work. But if you've been working with SQL statements, perhaps in other database systems or relational database systems, where we actually know that this is probably not the best practice to write your queries. A lot of dangerous stuff has happened because we have done it this way, right? So you're probably aware of the vulnerability, for example, for SQL injection. So a potential attacker can input a string into your statement that can, if you're using, let's say, SQL Server, that can potentially modify your data or even drop your entire database if you're not good at validating your user inputs, or if you haven't done escaping of your user input. So just simply concatenating it to a string can expose you to such an attack. So for example, if I pass, instead of just 500, and I pass another one, which is or 1 is equals to 1, which will return to true, then this statement will actually return all my data in product and not just the ones with the prices greater 500, potentially exposing more than what I am supposed to do, because 1 is equals to 1 will evaluate to true. Well, unlike though, I'll tell you a difference. And unlike though in some other database database systems where their SQL statements actually support also modifying data. So you can use SQL statement to insert, update, or even you can use their language to drop the database. That's not going to happen in Cosmos DB. I can't use any statement that can allow you to delete a container, for example, or modify your data because it's a read only. So you can only pass the SQL statements to be able to read data. But still, even that, yes, you can see here, you're still in the danger of doing or of encountering SQL injection attacks. So you really need to, of course, first of all, validate your inputs. But there's actually a better way to uh, to do this in your SDK using the parameterized query. So with the SDK, you can use the with parameter statement. So for example, here you can see I have my string, I have my select statement, I have my filter where p price is greater than, and then you define your value, your parameter with an at sign, so at lower, and this is your whole string. And then you create an instance of your query definition with your SQL, and using the Fluent SDK, you can write that with parameter and pass at lower and pass the value of 500 with that. And the query engine knows how to, of course, evaluate your parameter against the property that you're filtering on instead of just creating the entire string. And you can also have multiple parameters such as this one. So let's say you also have an AND with p price is less than or equals to an upper value. So you can have as many with parameters as you can. So that's a pretty nifty way of implementing filters in your SDK. Yeah.
Great topic to touch on, right? SQL injection, because it's something that, I mean, in relational databases, right? It's such an important thing to get right? We would never want to go and have your SQL queries just as one string value, right? Because it does leave you really vulnerable for somebody malicious to go and just add into like drop table, right? And that sort of thing. And Cosmos DB, Marilag, like you mentioned, like it's still a best practice, right? It's still something you want to follow, but because it's a read-only query language, like the potential risk is a lot lower. So you still definitely write your queries like this, but I mean, do keep in mind that it's a read-only query language.
Right.
One thing that we get from customers a lot, and just questions that we have from customers is, I mean, I'm used to being able to write queries or SQL statements, right, that add a table or remove a table or update data and that sort of thing. I'll share my own like tips and tricks, but anything that you've found, Marilag, that's been kind of helpful for like working with data at scale and when you can't go and write a SQL query?
Oh, so it's like if I have to create a lot of big data in one go, is that what you
Right.
mean? So how do you do?
Yeah.
Yeah. So sometimes, yeah. So, you know, my one of my colleagues is like he's so used to working with SQL Server like all his life. So he's always asking me, where is your management studio where I can just call insert all this 5,000 rows of data or more, thousands of rows of data. Well, actually, uh, I normally would write a tool that takes advantage of the Cosmos DB bulk update SDK. So that's one thing
Great idea.
that I use actually quite a lot for things like this. And I also sometimes I want to share. I don't know. Tell me if I'm doing something wrong, actually, team. So sometimes there's a need to also migrate your data, right? So your data model has changed. This is a no. A schema-less database, but we gotta admit that our requirements change, our models change, our maybe sometimes you have to delete a field or add a field or change the value of a field for some reason because you need to migrate it.
Yeah.
So one of the things is really also using the bulk executor, or maybe I just write my own from using the SDK and look through all the result set and then update it one by one if it's not so large. So that's what I usually do. So my migration scripts, the thing that I was really used to doing with migration scripts with, for example, SQL Server, is now kind of handwritten in C#, and actually quite efficient on it. It's because it's super easy to work with the SDK, whether it's a bulk executor or just a simple insert and upsert and delete methods from the SDK. So that's what I use.
Yeah, I agree. I would actually I use exactly the same tips and tricks. Using the SDK is really what we'd recommend here, right? Maybe something that a script that you can reuse if you needed to do this data update quite a bit. The bulk API, like you mentioned, is awesome for doing this at scale and for better performance. One maybe lesser known tip here is using stored procedures in Cosmos DB. I mean, that can be a nice way where if you have, let's say, repeated logic that you're going to run it again and again, and you wanted a way, let's say, for instance, to invoke it from the portal, having like a pre-written stored procedure that you use in Cosmos DB is a nice alternative to writing a like actual SDK code, right, to do this. There's really not a huge performance reason to do one over the other, mainly convenience. And the advantage of a stored procedure would be it's something that once you write it and you have it associated with your Cosmos DB collection, you can go and invoke your stored procedure from like the portal, for instance, rather than having to write code again and again.
All right. Can I invoke a stored procedure, let's say from my CI/CD pipeline, for example, if I want to automate something at deployment time? It's a totally random question, but I'm just curious.
If you used your SDK, you could I guess like you can invoke a stored procedure, I think, using the SDK, obviously. I think you can also invoke it using our REST API. So if you were, let's say, limited to using REST API, or something that's like built on top of a REST API, that might be one advantage of stored procedures rather than the SDK. You could just have your logic in the stored procedure and invoke it with REST API rather than the SDK.
Right. Yeah, I think I'm going to try that because that's one of the things that we encounter with the customer when we actually want to do the migration, and what if we want to do the migration as part of an automated process, as part of our orchestration. And I don't want a developer that has access to the, some access to the production environment that can run the script that updates something. I want this automated in an automated way. So something like I can always look up into if there is something that I can, run every time I have to deploy something, or perhaps maybe something for disaster recovery, something that you have probably updated and you want to rebuild your own data, and you have to run some of these stored. You have to run a series of stored procedures just to rebuild your corrupted data. I think that would be great. But worth looking into.
Yeah, it can be helpful, but of course, in most instances, people just like you mentioned, right? They just write code in the SDK to do this directly, and that's what I'll do in a lot of instances. So don't feel like you have to use stored procedures. It's more of just another option that's available. In some instances, it could be a little more convenient. So discuss it.
All right, now we have been talking about working with large data sets. So I think our next topic would be also very interesting, which is pagination.
Yeah, so let's dive into paginating query results and why you'd want to do that. So, I mean, the first thing I want to talk about, and this is actually even broader than Cosmos DB and broader than databases in general, is, I mean, why do query results need to be split over multiple pages? And to explain this, actually, I'm going to draw a parallel to like search engines, or really any kind of place where you're searching for data and getting a lot of results back. So whether it's Bing, Google, whatever your favorite search engine is, let's say I type in my search engine, how do I query data in Azure Cosmos DB, right? Now, whatever search engine you use, it's going to return a lot of results back, right? So, I mean, in this case, your client is, I mean, your web browser, right, where you're going and you're running this search. And the server would be, of course, I mean, is Microsoft Bing, right? That's going and returning results back. And in this specific case, I mean, this search returned, I'm counting my zeros right, 61.8 million, right, results. So, I mean, what would you do as a customer if you used Bing, you ran the search, how do I query data in Azure Cosmos DB, and you got 61.8 million results back? Like, what would happen there? First off, like your browser would probably crash, right? Like that's so much data getting back, right? That's probably like gigabytes of data potentially. Second of all, it'd be so much data that you wouldn't really be able to make sense of it, right? Like you wouldn't know where to start, right? It'd just be overwhelming. And third is like the latency for getting, I mean, 62 million results back is going to be like really incredibly high. So here, like if you ever use a search engine, like typically you'll get like 10 or 15 results in a page. I think Bing limits it to like 10 by default. And the reason that it does this is because there's a limited data volume per page that the server can return back to the client. There's also, a limited execution time per page. Like when you run this search, you're expecting to get results back in, let's say, a second, right? You don't want to go and you don't want to wait a really long time. So limiting the execution time per page will go and improve the execution time quite a bit. So that really helps the user experience here, right? Separating results into multiple pages. Finally, improving readability is also super important for these kinds of queries. If you got all 61 million results back at once, it would take a lot longer than if you, let's say, got them back in chunks. And I'm laughing a little bit because I can hear my dog in the background getting into something. So I'm going to step away for like 10 seconds. I'll be right back just to let him outside, and then I'll jump back here.
Sure. No problem. I know how that feels. I also just had a puppy. So I think we have another question from our viewer from Learn TV, going back to the query with the big static JSON data set. Can you query for the static data by calling a REST API within the subquery, or query for the static data by calling a REST API within UDF? So actually, you're essentially asking if we can call a REST API within the subquery so that I can query or get for that static data. I'm actually not sure, so we're gonna have to wait for team to answer that. But my best guess is that it's not possible. Team, I was just going through the question here about from our viewer from Learn TV, that asking if you can query for this, going back, let's take a step back. You presented that we have the static data. Can you query for the static data by calling a REST API within the subquery, or query for the static data by calling a REST API within a UDF? So can you build that static data?
Yeah, so you can do it in the UDF. If you really wanted to do this, you could put this call to an external REST API within the UDF. You can put it within the subquery. So you kind of have two possibilities here, right? You could put it within the subquery inside a UDF, and then the call to the external REST API is within the UDF. Or you could go and you could make the external API call outside of your query entirely, right? You could do, even before you run the query, do one call to the external API to get this text, and then go and use it in your query. That's the approach I'd recommend. If you really needed to, if the data, let's say, changed every millisecond, the data changed, then there might be a reason to put it in the UDF. But by having that, separate REST API call in your UDF, I would be very nervous about the performance implications of doing that. For instance, if that REST API took longer, the query execution could get really high. So if this is relatively static data that's not going to change too much, I'd recommend go and get this data with the REST API call before the query starts, and then grab that text as a string value, and then go and use it in the query. And that's, of course, probably pretty common with these sorts of instances. You might not have the text literally in your app as a string value, but rather maybe stored in some sort of REST API, right? Because the value could change over time, where you get that and then go and you use it in your application.
So it's I know that we have been through that topic, but I just actually got curious again. So you're querying against a static string data, or does it have to be JSON? So for example, if you're using the SDK and then you make a call to REST API, and then you got that JSON, can I pass that into your SQL statements then?
Yeah, that's exactly
right? That is what you would do.
Mm-hmm.
Yeah.
Yeah, that would be that I imagine is going to be fine for most use cases. Unless the data changed, I don't even think you need to make this call very often, right? You might not even need to make the call every time you ran a query. Maybe it could be done periodically or something like that, right? Because I think it would be rare that the data would truly change that frequently. So either doing it periodically, or at most doing it once you ran each query would be my recommendation.
Cool. All right. Thank you.
Yeah. And I see another question in the chat about pagination that we'll actually get into a bit later. So keep the questions coming about pagination. I'm going to kind of hold off until I've covered the basics, and then we'll go through all the unanswered questions about query pagination. So my dog is outside, all is good, and we have a much
Yeah,
more
yeah.
quiet recording session now.
That's actually why I did this in the office because my puppy, he's so sweet, and I know that I will, hear him when he does something, so I would be super distracted, right? So, but now I miss him because you mentioned dogs. All right.
Um, but yeah, we're talking about, I mean, just in Bing, right? If you were to do a search, I mean, pagination is required because you don't want to get a ton of data back, right? Because, I mean, if you got 61 million results back at once, your browser is going to crash. You don't want to wait for 61 million results at once because, I mean, if you use a search engine and it takes that long to get data back, like you're going to be not a happy customer, right? And then, of course, improved readability, right? Getting 10 results back is a lot more manageable than getting millions back. The same concept exists in Cosmos DB. Now, in Cosmos DB, every page of query results is capped at 4 MB. So this is actually true for any response in Cosmos DB. It's always capped at 4 MB. So if you do any sort of operation, the response is capped at 4 MB in size. Query execution is also capped at 5 seconds. So if you run a query and the results aren't available yet, you'll always get a response back from Cosmos DB after 5 seconds. So even if we're not done running your query, and let's say there's still some query results, you will always get a response back after 5 seconds. Finally, usability. Like many applications, like my browser, can only handle a certain amount of data back at once. So oftentimes for queries, using the max item count value, you want to configure just how many documents the Cosmos DB service sends back to the client. Now, the container class supports a lot of ways to iterate over multiple pages of results that we'll talk about today. And there's some options that you have to tune query pagination. And this is one way that you can tune like query client-side behavior. Really, your main way to, tune how many results queries return is with that max item count setting. So for this specific query here, it's going and it's filtering on products where the price is greater than 500. And we use the max item count value of 100 because we want to, for whatever reason, have results limited to 100 different products. Now, if we had omitted 100 from here, right? If we, in other words, hadn't had a max item count, the query would only be subject to the max execution time of 5 seconds and the max data volume of 4 MB. So this value is optional. If you don't specify it, you're still subject to this per page max. But of course, if you do specify it, if we don't hit 4 MB and we don't hit 5 seconds, we will cap the results at 100 different results. Now, there's something called continuation tokens in Cosmos DB. And this is an optional way to bookmark a query's current position so that you can resume later. And continuation tokens, they basically help the query engine avoid doing repeated last work. So in absence of using a continuation token, we basically, keep a record of the query state in memory. If the query doesn't finish in one page and it needs to resume in the next page, we basically store like the current state of the query in memory so that if we need to go to the next page, we don't need to go and like repeat any past work or anything like that. Continuation token is useful if you need to like stop query execution and then go and resume it at a later time or something like that. So if maybe you were building like a dashboard or building something where the client isn't going to immediately go and get the next page, a continuation token is a good way to go and persist the state of your query's current position. Now, some applications have like let's say a maximum request size or maximum response size or that sort of thing. So, if that applies to you, you can go and you can tune the response continuation token limit in KB. Like, let's say your application had a max request size of, like 4 KB. You could go and you could tune this response continuation token limit and make it smaller, right? So it'll fit within your application's requirements. In general, it's not something I recommend doing unless your application really requires it. In a lot of instances, the continuation tokens will be pretty small. The instances when they'll be large would be if you had cross-partition order by queries. If you had, let's say, distinct, they could be large. And in some other rare instances, if you have a lot of partitions and you're using certain query features, they could be large. But in most cases, they're small. So we make this available to you if your application needs it. But if it doesn't, I would just leave this at the default value. And I think they're capped, if I remember right, at like 16 KB automatically. So they don't really get too large. Now I'm going to jump over to a quick demo that I'll show about paginating query results. And this demo actually builds off the demo code in the lab, right, for this module. So in the lab code, basically you'll start out with a Cosmos DB account that you'll go and create. And you'll go and you'll add code to create a Cosmic Works container, a Cosmic Works database rather, and a products container that we go and we partition on the category ID. And then in the lab code, you go and you paste in a query. I mean, in this instance, it's just a SQL string, right? And we go and when we run the query, and then we loop through and we print out the results. Now I've modified this lab code a bit by adding in some query request options. And to start out here, we're going to set max item count to -1 and max concurrency to -1. Basically, what max concurrency says is we're going to go and the query engine is going to go in on its own, optimize how many physical partitions it's going to go and query in parallel. By setting it to -1, you let the query engine do this automatically. If you set this, let's say, to 1 or 2, what it's going to do is at most query 2 physical partitions in parallel, right? So in a sense, you're trading off number of threads that your client has and query execution time, right? Like the bigger you make this number, the higher the level of parallelization with the query. If you want this optimized, just set it to -1 and Cosmos DB will manage it automatically and generally bias on the side of optimizing latency with multiple threads in the client, right? One for each physical partition. We won't tune that value that much here. What we'll really focus on is this max item count value. And this, of course, is the max number of documents that will be returned by your query. So to start out, our query is a simple select star from SQL. What I'll do here is go and loop through all my results. And for each product in the results set, print out the product name in the description. And then I'll print out the request charge for each page. And then if there's a continuation token, I'll go and I'll just print that out for each page. And then if the continuation token isn't null, that means that there's another page of results. And I'll just basically print out what the next page would be. And then we'll press a key to go to the next page. I'll go and I'll run this. And of course, in this instance, I've set the max item count to -1, right? And if you've done this lab, you know that there's only about 300 documents in the data set. So if there's 300 documents and each document is about 1 KB in size, Marilag, I'll ask you this question. Do you think I'll get all my documents back in one page?
1 KB, 300, yes.
I probably will. It's not a guarantee, right? Like you can never predict exactly how many pages the query engine will need. But in most instances, if you think about it that way, you'll get a good sense of, will this query run in one page or not? So we'll go ahead and we'll run it and take a look. Seems like it's taken a minute. This is, I'll put in the disclaimer that that's not Cosmos DB taking all that time. It's my, I think my home internet connection or maybe the region I picked for Cosmos DB. If you ran this query in a VM in the same data center, it would run in like 10 or 15 milliseconds. So in this case, Marilag was right. It took only one page. The query cost 9 RUs. And I know that the query is done because it doesn't have a continuation token here. In other words, the continuation token is null. So we know that the query execution is complete. What I'm going to do now is change the max item count. Let's say you had an application that only wanted to get, I'll zoom in on this so you can see it. You only wanted to get, let's say, 100 results at once. If I go and I change the max item count to 100 and I run the query, the results now, they're going to span multiple pages, right? Because the max item count is 100 and I have about 300 query results in the select star from SQL. I get some of the results back. I get 100 back. That as a request charge. And I also have a continuation token here that I can use to basically go to the next page, right? And continue query execution. So I'll go and I'll run the query again, right? We just ran page 2. I'll press another key to go to page 3. And of course, now there's no continuation token. It's null, and I'm all done. So obviously, the smaller you make this max item count value, the more pages of query results that you'll have. In some instances, I found that customers don't want a max item count. In other words, they want an exact item count. And the way you want to achieve this in your code would be basically run the query, starting with the max item count of your ideal item count. And then when you run the query, if you haven't gotten to your max item count yet, run the query again with basically 100 minus the amount of results you've gotten back so far. So in other words, if you're looking for 100 results and you only get back 50 results in the first query, go in and run the query again with a max item count of 50, and then in your client code, combine those two results and 50 of each page and return them back.
So that's a really good way of analyzing your usage before you optimize, right? So to start with a baseline max item count. So is it possible that you set 100, but then you only get fewer because you have reached the cap?
That's correct, yeah. And the reason you would get fewer results, in most instances, it's due to just the size of the data, right? It's capped at 4 MB. So if you have 4 MB of data, it's always going to be split across multiple pages. Another big one is query execution time. If the query takes a long time to run, and it's rare for a query to take more than 5 seconds, but of course, if it does, your results will be split across multiple pages. Now, sometimes I've seen customers, like let's say in this case, you set max item count to 1, and you forget maybe to put in this while loop here. So I'll go and I'll document it out. Sometimes I've seen customers, they'll go and they'll run a query like this. The max item count, let's say that's low and without a loop, and they'll get this back in the results. Give it a second to run. They'll get back, of course, the first page of results, but because there's no while loop anymore, right? Because we've gone and we've documented this out, our code is going to stop, right? It's not going to go to the next page. And in some instances, here the first page it returned one document, but there's other possibilities where maybe if, let's say, it was a really expensive query, or maybe the execution time took a while, your results could actually span multiple pages, and the first page might not have any results yet. And sometimes the customer thought is like, hey, like my query didn't seem to return anything. What do I do? So it's super important when you're writing queries, always put this while loop here. Like your query execution should always be wrapped in this while loop that we have right here. All of our samples that we published have this, and it's only 2 lines of code, right, or 1 line here, but it's super important that you have this. We call this draining the query, basically going through and continuing to execute the query until there's no more pages of results left, right? If you don't have the while loop, it's possible that if like the number of pages of the query results changed, it could like break your code. And putting this while loop here makes it so that if, let's say, the number of query results changed, or maybe there wasn't results on the first page, that your code is able to handle this in a really robust and clean way.
Right. So going back to the max item count, can you use this if you sort of want to save on RUs and like throttle your call if you know you're going to get a large batch of data and you only have, maybe a limited throughput? Let's say you're not using serverless and then you want to get a bunch of data. Would you use it that way, or?
Yeah, and so I'll actually show, that's a really great point. So I'll use an example here. Obviously, this is a very simple query, right? But let's say you had a different query that needed to return a lot more data. If I go and I set it to 100 and I run this query, the RU charge is going to be probably, probably around like 4 or 5 RUs. It's about 4 RUs. If I go and I set this to 200 and I run it again, each page is going to cost me probably slightly more. Cost me about 6 RUs. Obviously, in this specific example, the charges are so low that this isn't really something you practically do. But at a much larger scale, if let's say you did have a lot of data to return back, I mean, tuning this value to get back data more slowly is a great way, like you mentioned, to avoid throttling, right? And manually kind of spread out the data that you're getting back over time. So, I mean, if you had a query like a select star query that's returning a lot of data, tuning this max item count value is a great way to save on RUs. I found actually it's in a lot of instances less about RUs and actually a lot more about the client costs. Getting back 200 results back to the client isn't too big of a deal, but I mean, if you take this to the extreme, and let's say the number of results that we would get back in a page now is unbounded, right? If it isn't capped at a certain number of documents, that could be something that you as a developer want to maybe spread out over time, right, using max item count.
Mm-hmm. Yeah, and it's I'm really happy to know that it's really easy to implement it using the SDK. So a lot of the developers are whenever they hear pagination of their database, oh, how am I going to do that? And then, oh, I don't want to deal with that for now, so I'm just going to return everything to the client and let the client do its own
Yeah.
pagination. But this one is just super easy, so that's really good to know. Really
Yeah,
simple way.
it's meant to optimize really for developer friendliness here. And the query engine, I mean, it there's a lot of complexity. Like all you really need to do again is put your code in this while loop. But I mean, behind the scenes, this is actually doing a lot more than meets the eye. So if you literally are writing queries against Cosmos DB, the approach I'd recommend is just take the samples that we have, copy and paste that, and then edit it for your use case. It's really meant to be simple. And if you find that you're spending a lot of time on this, you're probably overthinking it, and you can really just want to think about like adapting something that already exists, right? And in most instances, it's not really going to require very many changes on your end.
That's true. I think we still have time for one more question. I mean, we have time, but let's take a question from Fuel Snibble on Twitch. So, asking what happens. This is very interesting. What happens with a paginated query if objects are added that match the query? Or can you get duplicated objects in the paginated query if data updates occur between paging?
Yeah, I'm going to answer this with an example. It's a little hard to change the data on the fly, but I'll use a query and a kind of example and kind of talk you through it. So let's say instead of this select star from C query, I'm doing like select star from C, order by, let's say, C dot ID. And I'm going to set max item count to 1. So this query, when I run it, will get back basically one result per page, right? Like we'll go and we'll have many pages of results. And because we've set max item count to 1 right here, we have at most one result per page. If I go and look at the results here, we have one result in each page. If you go to page 2, we have another result. Page 3, we have another result, and so on. Now, this query here, we persist the state of where we are with the continuation token, right? And here we've gone and we've looked at the continuation token, but if you didn't use a continuation token, I mean, this state would be basically stored in memory, right? Your bookmark of where you were in processing the query results. And the reason I make this an order by query is because it becomes a lot easier to explain. In this specific instance, let's imagine, right, that your ID value changed. I realize I might not have picked the best example because ID in Cosmos DB is actually a special property that can't change. But for the sake of the example, let's imagine that it can, right? Let's imagine that for this particular example, you can change ID. And let's say that we're sorting here in ascending order. Let's say that maybe when you run this query, you go and you take this document here that was returned, and you go and you tune its ID value by basically, in other words, you update its ID value constantly by incrementing it, right? If that were the case, right? If let's say I returned, let's say ID 1 here, and on the next page, I look for the next ID value. If I went and I changed that same document's ID value to a bigger one, it's possible that I could get that same document back more than once. It's also possible if, let's say, there was ID value 1,000,000 and we had returned the first few pages, but before getting to 1,000,000, we changed that document's ID value from 1,000,000 to a smaller number. It's possible that we could miss returning that document, right, and not get it back. So, I mean, the way you want to think about query results, right, over time is when you run a query, each page is basically a snapshot of the state of your data at that time. But like across query pages, right, like you're not necessarily going to have the same data, right? Data can change over time, and the continuation token doesn't persist the data that was read so far. Rather, it persists your current bookmark, right? In this case, it persists like the last ID value you read. And if your query results do span a lot of pages, and if there's a lot of time in between executing different pages of query results, it's possible that if, let's say, something you're sorting by changes or the data changes, it's possible that you could get like the same document back more than once, or maybe not get a document back at all if the data is really changing that frequently.
Right. So talking about if there's like a long period in between the different pages, let's say first so what you're trying to do is to get a set of data in one page and do some long running processing on that page first, like for example calling another REST API or doing
Mhm.
some processing with it before you fetch the next page. So this can potentially happen. So that's something that you have to really think about in your
Mhm.
design, your model. And maybe what about if I do it in parallel instead, right? So how does the max parallel works with the paging?
So this is here. It's the max degrees of parallelism, or the max
Yeah, max
concurrency is what
concurrency.
it's
Yeah.
called. Um, Basically, if you set this to -1, the Cosmos DB system manages it for you, and basically will generally optimize on the side of better parallelism, better concurrency, lower latency. If you go and you set this, let's say to, I don't know, 10 or 15 or a precise number, this is basically the maximum number of threads that we'll have for querying your physical partitions in parallel. If you make this number
Mhm.
bigger, the query execution time will be lower, but of course there'll be more client resources used. This number can affect the number of pages of query results, right? If you went and you set this to 1, and in this case, I only have one physical partition, but let's say, for the sake of an example, let's say I had 1,000, the query execution is going to be run sequentially, right, for each of them. There will be no
Yeah.
parallelization. So you're very likely to have many more pages of results than if you set this
Mhm.
value, let's say, to 1,000, right? If you set it to 1,000, it's more likely that you'll get a smaller number of query pages back from the server rather than if you set it to 1, right? Because they're all just being run sequentially, and here there's a certain degree of parallelism. So it's
Parallelism.
certainly something to keep in mind. For queries that run a lot across a lot of partitions, sometimes it actually is just more efficient for the query engine to return results across multiple pages. So even if you set this value to -1 and you have a query that runs rather quickly, it's still possible that your query results could be split over multiple pages. In some instances, it could just be because that particular query feature runs more efficiently. In other instances, maybe there was a little bit of throttling, so you had to split up the results. But for whatever reason, if you go and you put your code within like a while loop that looks like this is how you protect yourself against the unexpected, right? As long as you're keeping your code within that while iterator has more results, as long as your code that processes the query results is within there, you will be in good shape. And I mean, regardless of the number of partitions, regardless of your max concurrency, your code will work, right, and process all the queries results.
Right. All right. I have learned a lot, and I hope that our audience also learned a lot. I'm sure they have. Oh, there's one more question. Can we squeeze one more question before we go to the knowledge check?
I think we
I
can.
think we have about 10 minutes. All right. So there's a question: is there any performance impact on client SDK processes due to high volumes data of being received by running select asterisk from SQL?
Short answer is absolutely yes. If you
Yeah.
don't need select star, don't run select star. I did it in my example because I wanted to keep it simple, but I mean, in practice, if you don't need every single property projected back, you should only return the specific properties that you need in your query results. And this is not specific to Cosmos DB, right? This is across the board. It's
Mhm.
going to significantly decrease the amount of data that's sent over the wire if you did like select value, a specific property, rather than just a blanket select.
Right. So definitely, there's actually I have a related question. I was going to ask you that earlier today. So when we were doing joins, can you just for the benefit of our audience, can you do a star when you have joins?
Um, I don't think we allow it.
I don't think so.
I
Yeah,
don't
yeah.
think
As
so.
far as I can tell. So
Um,
that's like one of the things that I sort of forget sometimes. So I was
yeah,
doing joins, and then I'm just all of a sudden right, just for just when I want to query something, not to use it on my application. I just want to do select star and then join to just
yeah,
verify something, and then I can't do that.
yeah,
So that's was worth remembering. So maybe you do need in some few cases, but maybe you feel like you need all the properties that that you need in your application, including the items in your child arrays when you do the joins, and then doing a star from that. But you can't do that, so you will have to manually specify the each and every field from your cross product query results, if I remember it correctly.
yeah. You have to just specify the properties there when you're doing a join query. It doesn't. Um, you can't just do a star. But I mean, right? Like our example used select star, but in most cases in practice, like, and if you look at what customers are using in the product, most customers do not just have select star queries. Usually, they do go and project
Yeah,
specific properties.
exactly. All right, should we move to our
Let's
knowledge
do it.
check? Let's do it. Okay, so for those of you who are watching us live, please do answer and we can see how many got it correct. So, first question, you have a container of products with JSON documents that contain a string property named name. And the JSON documents also all contain a property named tags. That's an array of string values. You are tasked with authoring a SQL query that will create a cross product of the document names and tags. Which SQL query should you use? So A, select P name T tags index 0 from products P. B, select P name T tags from products P. Or C, select P name T from products P, join T in P tags. That's a handful to say, but I'll let you answer, team.
It seems like most people got it right.
Really? Cool.
It's great. Everybody picked C, which is awesome. Obviously, you need a join here, right? And I think this might be the only response that has a join, so it makes it really easy. And as soon as you see that requirement, you should think join in your head, and then scan through the results, the choices, right, that have join in it. So in this instance, it is indeed C.
Yeah.
You need the join here, and you can, of course, if you need to return the data back, you need the join. If you only need to filter on it, you could use a join. Or you have the option of like a subquery, right, with exists.
Right. I mean, I haven't taken the certification yet, and I'm really planning to. But this is if this is the sort of question that I get, it'll be easy. But be aware that it could be sometimes misleading. So you would see two, three different joins with a little bit, different format, and you say, okay, and then you start thinking about how you did it previously in SQL. That can confuse you. So make sure that you get it right with the way joins are written in Cosmos DB SQL. All right, for the next question, which method of the Microsoft Azure Cosmos Container class takes in a SQL query as a string parameter and returns an iterator that can be used to iterate over the query results as deserialized C# objects? So, A, we have get items query stream iterator, get item query iterator, or get item link queue queryable. I'm going to go with B. And B is the correct answer. Mind if you just quickly tell us what the other tools are used?
Yeah, I'm honestly, I would say it's A and B are both kind of correct in the sense that they both take a string parameter. The key difference is the second part, right? Returns data as a deserialized C# object. The stream API, right, with the stream iterator doesn't do that. So that makes B, right, the only answer in that case. Like if you didn't need to get your data back as a POCO, you could use the stream iterator. So choice A. If you did, then you would obviously pick choice B, which is the answer. Choice C, it takes input as like a link query, right? It's not going to be a SQL query string, so that makes B, of course, something that you could certainly use to query data, and many customers do. But of course, that rules that out, right? Because the input is not like a SQL query string parameter.
Right. But that's really a good thing to remember for developers. You don't always have to deserialize your query results into your POCOs. So if you just need to return the data that you're getting from your database as is to your client, then it's much more efficient to use the stream.
That's right. Yeah. That's why we have it.
Yeah, and I think everybody got it right too. So we did a good job, team, of teaching this episode because all our audience got it correct. So thank you for participating. And now we just want to summarize what we have learned today. We have, earlier today learned how to write correlated subquery, and team did a fantastic job showing us also some extra tips and tricks on how to make this more efficient. We talked about how to create cross-product query and how it differs a little bit from what we were used to with relational databases. And we also learned about pagination and also using parameters with when you're doing filtering in your queries. So I had a lot of fun team. So, are you also doing another session with this, or is this is your last one, or this is first and last so far from the series?
To be honest with you, I wish I knew the answer to that. I'm not that far ahead of my calendar, so it's possible you'll see me again. Hopefully you do, but it's I don't know. This might have been the only one I signed up for. I'm honestly not 100% sure, but we do have some upcoming sessions that I definitely recommend checking out. Marilag, do you want to talk a little bit about the next one? I think the next one might have been on indexing. Is that right?
Yes. So the next one is actually defining indices in Azure Cosmos DB. This is going to make your queries even more efficient and really understanding, the underlying hood on how Cosmos DB indices data. As we all know, there's automatic indexing of all the properties, but then you can tune that, and you will learn that in this session and why you should have to do this. And again, I just want to remind everyone that this series will really help you get to that certification. So keep doing it, keep going through the exercises on MS Learn Live, and don't forget, like, we have our business experts and our community leaders doing this series behind the scenes, so we can answer as much questions as we can. So this is a really good time. But if you're watching the recording, don't fret. Of course, you have all the channels. The Cosmos DB team is always ready to answer your question. Team, can you tell us about where to reach you? Or the team, if they have some question, where's the best place to ask questions about Cosmos TV?
Yeah, Twitter. Twitter is a great place to ask questions. So I think my Twitter it should be showing up on the screen now. You can tweet me personally. If it's a question about querying or change feed or integrated cache, I'll probably know the answer. If it's not, I'll probably just tag someone else. So any of those areas, tweet me, and then across the board, you can just tweet. The Cosmos DB team on Twitter, and then we can certainly help and answer your questions.
And of course, follow your blog. There's a lot
And
of
follow the Cosmos
information
DB
in there.
blog. Yeah, lots of good stuff about queries, and of course, other PMs will write about different parts of the product.
Yeah, and then of course the best way to learn is to do hands-on. So you can always start with the free edition of Cosmos DB if you just want to try out things. So there's really not, or if you are accessing the Learn, then you have the labs there where you have access to all the VMs and tools that you need to get started. So good now, it's a good time. Well, right. So I just want to thank everyone. Thank you, team, for joining me today.
Really?
Say hi to your dog, and I think it will be happy that
Good
this
now.
is
Yeah.
over. Right. Thank you very much, and see you all in the next episodes of the Azure Cosmos DB Certification Study Hall. Thank you.
Thanks.